Hello everybody. In this lesson, we are going to look at the sampling distribution of the means. So we are going to recognize that the sample mean can be regarded as a random variable, and we denote it as x with a bar. Prove and use the expected value of the sampling distribution of the means and the variance to be these ones. Use the fact that if x is normally distributed, then the sampling distribution of the mean has these parameters and is normally distributed as well. You might ask, what happened if the parents' distribution is not normal? And that's what we are going to see in our next lesson. Here I'll remind you that in class, in the previous lesson, we started with a parent distribution and this Excel spreadsheet continued. This population is a population of the boys' weights. Then each of you had a tab in an Excel spreadsheet where you used our previous learning and you generated samples of size 1, 2, 3, 4, 5. So you started with a random number generator and picked from that distribution the values accordingly to the rank given by the random number generator. So these were the values chosen for this sample number 1, and you calculated the mean. All these means will form a new distribution. From each of your tabs in the spreadsheet, we collected those means and we formed a new distribution. As you see in this case, the new distribution doesn't necessarily look like normal because we have a limited number of samples in our distribution. The more samples we would take, the closer this will be to a normal distribution. If we will take all possible samples, the distribution that we'll get will be normal. So on the next slide, we will look at the mean and the variance of this new distribution. How are they related to the mean and variance of the parent distribution? This distribution is called the sampling distribution of the means. So it's a new distribution, sampling because it comes from the samples of the means, because what I calculate from the samples is their means. So it's a sampling distribution of the means. Similarly, I can have the sampling distribution of the variances if in each sample I calculate the variance, or the sampling distribution of the modes if in each sample I calculate the mode. However, in this course, we study only the sampling distribution of the means, which is the most interesting out of all that I enumerated before. Let us start with the parent distribution as being normal with the expected value mu and variance sigma squared. Let me take samples of size n. In the examples that we took previously, n was 5. So I'm going to calculate the mean of the sampling distribution of the means. So how do I form the new distribution? Is that I form a new distribution, I call it x bar 5. That's a notation that we use to show that it's a distribution of the means and the sample sizes is 5. It's an internationally accepted notation. What do I do is you do x1 plus x2 plus x3 plus x4 plus x5 over 5, meaning that it's like you imagine as you have 5 clones of the same distribution, and you take randomly one number from the first, one from the second, one from the third, one from the fourth, and from the fifth, and you divide by 5, and you divide by 5 because there are 5 of them. That's exactly what we've done in our Excel spreadsheet. So that's how you form the sampling distribution of the means with samples of size 5. You can pause a movie and try yourself to find the expected value of x5 and the variance of x bar 5 in terms, of course, of the mean and variance of the parent distribution. So pause the movie and try yourself. I hope you got the same, that the expected value is of the sampling distribution of the means is the same as the initial variance, expected value, and the variance is sigma squared over 5. Similarly, if we replace with n, we get that. So the expected value of the sampling distribution of the means is the same as the expected value of the initial distribution, and the variance is smaller, is sigma squared over n. As you see, the new distribution will have a variance that is smaller than the parent distribution, and think logically, it is expected to be like this, because when you take samples of size whatever n, and you calculate the mean, in this sample is likely that you have smaller and bigger values. So when you average them, the number that you get will be smaller than the outliers in this distribution. So the variance will be smaller. Now, what else we would know if we would continue collecting data on the previous page and construct completely that sampling distribution of the mean is not only that the expected value and variance are as we found them here, but also the shape of the sampling distribution of the means is normal. So if we start with a normal distribution, then the sampling distribution of the means is normal with the same mean and the smaller variance compared to the parent distribution. Finally, I want to draw your attention at this example. Please pause the movie and read the example. Try it yourself. When you read the question, you see that they ask you what's the probability that the mean volume in the 5 bottles is at least 504. So students will calculate the expected value and will state that is the same as a parent distribution and will calculate the variance. And then they jump directly here. It is very important to write that this distribution is normal. So that letter here is very important because that's your thinking. You know the shape of the sampling distribution of the mean, so you need to show that you know it. The fact that it's normal allows you to use that formula to calculate the probability. If, for example, you didn't know that it's normal, you would not have been able to apply this. Or if the distribution had been binomial, you'd do something else. Of course, it is not. So my point here is that it's very important when you form a new distribution to give it a letter. So here, see, we have another name for it, and to state the shape of the distribution together with its parameters. And this will allow us to calculate probabilities as we know for that particular distribution.